Dear friends, welcome to this electrical engineering knowledge sharing channel. We are discussing 11 kV switchgear schematics. This is the last video on this 11 kV switchgear schematics, that is the drawing a single line diagram. Now, to draw or to develop a single line diagram, we need some basic documents. Without the basic documents, we cannot develop this single line diagram. The intention of this single line diagram is to show in overall how many panels are in the existing switchgear or of that new switchgear which you are going to design, and what are the various power equipments are present there, what is their rating, how they are interconnected, all these things to be represented in the single line diagram. To develop the single line diagram, the basic informations which we need that we can retrieve from your conceptual design or from the feed design. First of all, we need that complete equipment sizing calculation. All the power equipment sizing calculation like generators, transformers, motors, circuit breakers, CT, PT, cables, all the equipments sizing calculation is required. Based on that sizing calculation, and once we decide the switchgear rating, then only we can develop the single line diagram. So when we are developing the when we start the switch to develop the switchgear single line diagram, at that moment we have in hand all the power equipment sizing calculation, including cable sizing calculation, and overall hookup arrangement also we have already planned and we are aware of that. Based on that, we are developing the single line diagram. So based on that, we have planned, or we have conceptually we have decided that for this is a 11 kV switchgear. For the 11 kV switchgear, for the generator feeders or otherwise which is very emergency or urgent equipment like generators, like your suppose there is a gas compressor motors, those type of equipments will be supplied from by dual feeder. Each equipment will be supplied by dual feeder. So if any of the feeder has some problem, then other feeder will cater power. So there will be uninterrupted operation of the plant. That is our purpose. That is our intention. So based on that, we have decided the generators, all the generators will be connected by dual feeder, dual breaker. That means this switchgear we have already discussed that switchgear has a two bus bar A and bus bar B. So these generators will be connected both bus A and bus B by dual feeder arrangement. Okay, and all the transformers and motor feeder will be single connected because it is single feeders, and big motors or the process compressor which is connected by motor, that and the transformers that will be connected by the like a generator feeder, dual feeders. Based on that, we are going to develop the single line diagram and all the power equipment sizing, everything in our hand. So I am showing one typical for the generators or dual feeder arrangement. Then I will show another single line diagram for the one feeder which is supplied by one feeder only, like a transformer feeder or motor feeder, and that will be copied for all the panels or all the feeders, all the equipment in the plant. So this total thing to be developed in a one drawing only. That's why it is called overall single line or single line diagram for 11 kV switchgear. As I don't have enough space, that's why typically one by one I will be showing. But keep in mind that all the feeders to be shown, whichever are connected to A bus, that will be showing on the A bus. Whichever are connected to the B bus, that will be connected to B bus. So first, how we will start this? We are making a bus bar. This is the bus bar, main bus bar, power bus bar. This sizing of the switchgear already in our hand. This is a bus A, and start from here is a bus B. Okay, so bus A, it will be continuing this way. So all the feeders will be connected. This is at this moment we are going to discuss about this feeder. This is one of the feeder for the generators, and this is another feeder for the generators. One is connected to bus A, another is connected to bus B. Okay. Now when we are writing the switchgear, first here in this bus bar, over the bus bar or over this over here, we have to write down this switchgear brief specification. This switchgear is 11 kV switchgear. So in this location, over the single line, we can write down it is a 11 kV switchgear. That is first of all 11 kV. what is the current rating of this switchgear? Suppose this switchgear is a 4000 ampere rating. Okay, so we'll write down 4000 ampere. Then what is the phase? It is a 3-phase switchgear, right? 3-phase. Then what is the your frequency? Suppose it is a 50 hertz frequency, that we can write. And then we have to write down one important thing, switchgear short circuit capacity. We have already discussed during our short circuit calculation. Any equipment short circuit rating will be, there are two, one rating is a current rating, another is a time rating. Suppose this switchgear we are considering short time rating is for 3 seconds and the short time withstand current capacity is 40 kiloampere. So we'll write down here 40 kiloampere within bracket 3 seconds. So this total thing will be written over here along the bus bar. So from this we can make out this bus bar, this copper bus bar. What is the rating of this bus bar? Bus bar is 4000 ampere. Short time current rating is 40 kiloampere. The voltage rating of the bus bar is 11 kV. The full load current of the bus bar is also 4000 ampere. Okay, and 40 km short circuit. This bus bar is a 3-phase bus bar. Means there is a 3 bus bar. Bus A, bus B. That is your R phase, Y phase, Z phase. This single line which we are showing over here, this is actually consisting of 3 bus bar, 3 bus, R phase, Y phase or blue phase. Okay, these are the 3 phases that is showing by 3 phase, and the frequency of the switchgear is a 50 hertz. That is to be written over here on the single line diagram. That is the first thing. Second thing, we have to show the bus bar A and bus bar B. Then we have to go to the all the feeders. Now all the feeders we divide into 2 parts. One is the incoming feeder, another is the outgoing feeder. That means which is supplying power to the switchgear, that is considered as the incoming feeder, and this switchgear, the equipment which is scattering by the switchgear, that is we call outgoing feeder. So in this case, what is the incoming feeder? Incoming feeder is a all the generators feeder, and if this switchgear is hooked up with another switchgear which can supply power to this switchgear, that will also consider as a incoming feeder. That means if there is a overhead line or some other substation, if we take the power to the switchgear, that feeder will be considered as a incoming feeder. So we are considering this is an isolated switchgear. That means it is an offshore or some island switchgear where there is no utility power supply. So this switchgear is a only supplied by the generator. There maybe we are same in line with the previous discussion. We are considering we have 4 generators, and we are showing for the 1 generators only here, but other 3 generators will be similar or identical arrangement. So these generators will be connected by 2 feeder, one feeder from the bus A, another feeder from the bus B. So I am showing the bus bar in this way over here on the left hand side, and the feeder we are showing on the right hand side. So from here, first, what is the power equipment required for this switchgear, for this generator feeder? First we need the isolator. We are considering the SF6 fixed type switchgear. In the fixed type switchgear, to identify the service test position, we have to put a isolator. So first we have the isolator connected from the bus bar, and then the isolator has a isolator, then the arc switch. But we are using a isolator cum arc switch over here. That is the symbol for the isolator cum arc switch. This is going to the bus side connection, and then this is your driving rod, and then this is a earthing position. When this will be connected over here, then it is a disconnector is connected. When this is connected over here, then the disconnected is grounded out. So that is we are showing over here. That is first our disconnected, and this disconnector is a motor driven. That is we are showing over here. That is the disconnector. After disconnector, what we have? We have second connection with the disconnector. Outgoing is connected to the circuit breaker. This is a circuit breaker symbol we have used over here. Line, then there is a cross, then this is a contact. This symbol we are using. Somewhere you can see the symbol like this. Also circuit breaker symbol. Somewhere you can see the circuit breaker symbol like this. Somewhere you can see the circuit breaker symbol like this. This symbol means this circuit breaker is a removing type. That means this circuit breaker is not fixed type. It is a removal type circuit breaker. You can change the position, service position, test position, isolated position. That is a withdrawable circuit breaker. That symbol we put like, we put double arrow this side, then we put the circuit breaker this symbol, and then we put downward 2 arrow. But as we are considering SF6 circuit breaker, and this circuit breaker we are considering fixed type, so that's how we are not using the drawout symbol. It is a fixed symbol. So this is the circuit breaker. So this is the circuit breaker over here. After the circuit breaker, then this is a bus bar. This is a bus bar coming. We have already discussed this isolated and disconnected, connected where it is on the bottom part of the circuit breaker. From there is a bus bar running. That over the bus bar, various sensing devices are located. What are the sensing devices? The sensing devices are various CTs and PTs. Now first we have to identify how many CTs will be there. Now for the generators. Now in this case of generators, for this type of rating, this is for a 20 MVA generators. For that type of generator, we have a one relay which will include all the protection functions of the generator. That is one relay. Then there will be a multifunction meter, the meter which will monitor various parameters of the feeder. Then we have a bus bar, because this is 11 kV switchgear, have a bus bar differential. So there will be bus bar differential CT. Then this 11 kV generator has 20 MV rating, so it needs a own differential protection. So generator own differential protection CT will be there. That is another CT. These are the four major CTs required for this feeder. One for his multifunction protection relay, one feeder. Then independent differential protection, generator differential protection, one CT will be there. Then as this switchgear has a busbar differential, so for the busbar differential, one CT will be there. Then the multifunction meter, which is monitoring various parameters, for that one CT will be there. That four CTs are there, and all the CT already sizing is already calculated. What is the ratio required? What is the BA required? What are the protection class required? So all this thing will be written on the side of the CT. So we are showing here four CT. One CT, this CT is for multifunction meter. That is intelligent protection relay. I have written over here intelligent protection relay. That relay is a multifunction protection relay. Inside the relay, if you look, what are the protection functions are there? There are various protection functions inside. If we see this relay, this is the multifunction protection relay. There is a, you start from there. There is a 27, then 50, 51, 50N, 51N. Then you have a other protection like a 50BF breaker failure protection. Then if you want more protection, if you reverse power protection, that could be included. If you want as a distance protection required, you can do that. What about the various earth fault? All this we have considered. If you want 67 directional phase fault, directional earth fault, all these things can be included within this. That this relay block will, when we show the single line, we make the complete block. Then inside the block, all the functional element we write inside. Then also we can write ammeter, voltage, then your VA, then kilowatt. That is also we are monitoring by the relay. Relay has, we have already discussed. This relay has not only protection, it can also monitor various electrical parameters. All this thing we write inside the box, and that box is this box. So this, for that there is a CT. That CT ratio is a 1600/1. We are considering 1 ampere CT. It has some BA rating. So when we are writing the rating over here, we have to write in this way. Okay, we have to write down first ratio. Ratio is 1600/1. Okay, then suppose this CT is a 10 BA. We have to write down 10 BA. Suppose the protection class we need a 10P20. So we have to write down protection class of the CT 10P20. These are the required for the normal protection relay CT. So that details will come over here for this relay. Similarly, the multifunction meter, this is also another CT, same ratio 1600/1. This ratio will be decided based on the generator rating. So that we have already calculated. Similarly, for this multifunction meter block, that will also show in the same way. What about the various function inside the multifunction meter? That inside the block we write down, suppose ammeter, suppose current measurement, voltage, then BA or kVA, then we have kilowatt, then kVR, then power factor, then frequency. Suppose all these things we are metering. So this block will write down all these things. Then on this side we will also write down this ratio VA. Then the protection class for the CT, maybe for the metering CT protection class is different. So that also to be written over here. In this way, all this detail will come over here. Then we have to come for the busbar differential. Now, as the busbar is a 4000 ampere, we have to calculate how much maximum busbar current can flow normal condition. So we have considered is a 2005 ampere CT. So this 2500/1, this is a busbar differential CT. So we know busbar differential CT, all the CT for busbar differential, all the feeder has a busbar differential CT. That CT will be the same ratio, same VA, same protection class, same knee point voltage for the busbar for the differential protection CT. In addition to this, here the protection class is for the differential protection, we write down PS class CD. Okay, PS class CD, and then we have to write down knee point voltage of the CD. That also we need to calculate. So this all this parameter will coming and under the bus bar differential here CD. So bus bar differential CD, when we put over here, this bus bar differential CD ratio, what will be 2000 by 5 we have considered. Suppose the VA is a 20 VA, protection class PS class CD, and the knee point voltage suppose 100 volt, that we have to write down over here. The knee point voltage, all this thing will come over here. Okay. Then the next CD is a generator own differential. We have already discussed the generator differential protection. If you look into my old video, there is a generator protection arrangement is shown there. So there is a CT required from the feeder. So that CT is this. We have calculated the generator full load current. Based on that, we have decided that the CT ratio is a 1500 by 1. As it is a differential CT, it will be the same. 1500 by 1 is VA rating to be retained. Protection class will be PS. Knee point voltage to be calculated. All these things will come over here. So that is for the 4 CT details. So this 4 CT will meet our requirement. Then as it is a generator, so generator needs a synchronization. When we want to close the circuit breaker, we can close the circuit breaker with the bus only when this incoming voltage and the bus voltage are identical with the same frequency, same phase sequence, same value, or there is a sequence of parameters to be identical for synchronization. So how we will do that? In that case, we need the bus PT, bus voltage supply, as well as the generator voltage supply. Generator voltage supply we measure by the generator line PT. So this is the line PT we have shown over here. This is a 11 kV generator. So line PT is a 100 kV, 11 kV by 110 volt PT. So this PT also, it has a VA rating. It has a accuracy class. All this thing will come over here. What is the kVA capacity of the PT? What ratio is this kVA capacity, and the PS class we have to write over here. So then this PT will come over here. Where it will come? It will come to this relay. If this relay do the synchronization, then these will come to the relay. So this relay, if this relay has a 25 function, that 25 is a synchronization function. If that's there, then this PT supply, secondary PT, this will come here, and then another PT supply. There is a bus PT over here. Okay. If you look actual single line, there is a bus PT. There is a bus PT over here, or you can show it this way. This is a bus PT. That bus PT supply also come to this relay. So this relay, if this relay contains synchronization, then it has a 2 supply. One supply over here, another supply from this. And if this synchronization is somewhere else, we do it. In that case, what we can do? We can take this bus PT outside. Then from here, we can take to manual synchronization, auto synchronization. Then external any other, like AVR also need the line PT. AVR, we can take the supply for AVR from here. And at the same time, this PT supply for this relay need the PT supply, because relay need to measure the various parameters. So the relay need the PT supply. Then multifunction meter need the PT supply. So all the PT supply also tap up from here. There is a MCB over here. So after the MCB, the one tapping is coming over here to supply the multifunction meter and this relay, and the other tapping is going to the outside for the synchronization, AVR. All this thing will go over here. So this way, this is also to be shown. This is for the, and then it is going to the terminal from where the generator to be connected, right? Now here is one problem. Now this feeder, it is not only supplying to this generator supply is not coming over here only. If required, this could be supplied to the other bus also, from other bus. We have said it is dual feeder. That's why there is a hookup from this point to A bus panel. So that hookup we are showing over here. At this point, at the outgoing point, you can say there are 3 terminals. 3 terminals for the generator feeder. One terminal is going to the other bus. This is a power cable connection between this bus to this bus. B bus to A bus to be connected by the outside from the panel. The cable will come and it will go to the A bus. Okay, that is the cable connection between the A bus and B bus for the generators. And this from the bus bar, one terminal one bus bar is coming, bus point is coming over here. And then from this point, another point will go to the generator connection. So this is I am showing over here 2 GT, generator transformer. It is going from this, when this line coming over here, there is one terminal over here. This is connected to this bus. Then from here there is a shorting to the other terminal. From here it is going to the A bus. And then it is connected to another terminal. That terminal going to the generators. So generator part I will be drawing afterwards from here how it is connected. Okay, this is the B bus connection details. Now for this total generator, I need only one PT, that PT over here. Okay. Now this PT supply also need to be going to the A bus. So what we will do, from here also we can take the PT supply to A bus. For the A bus, same arrangement. For the A bus also we have the identical equipments. The same CT is there. For the, this is for the relay. This is the A bus. You see, this is the A bus. For the A bus, this is a single line. So in the same way, here is a isolator. This is a breaker. This is our breaker. Then these are the 4 CT. This is the 1 CT. These are the 4 CT over here. This first CT is for the relay CT. This is the relay CT 1600 by 1. This CT. This is a relay CT. This is a 1600 by 1. This CT also 1600 by 1. This is for multifunction meter, MFM. This CT for what? This is a 2500 by 1 CT. This is for busbar differential, going to busbar differential. And the last CT is going for the generator differential. So this is the last CT over here. That is going to generator differential. What is the rating of that? 1500 by 1. Okay, these are the CT. Same identical arrangement we have shown over here. Then it is coming to the terminal, end terminal. From this terminal, we have shorted to another terminal here. From this terminal, it is going to bus B. So bus A, and this is the bus A. From these and these, actually it is a shorting, connected. It is connected by a cable. Okay. So this between A bus and B bus getting connected, and this generator is connected to the B bus. Okay. So when I need to run from the B bus, this breaker will be off. So power will be coming this way. And when you want to run the generator from this bus, then this breaker will be off and power will be coming from the generator through this cable to this bus. This is the way of power flow. Okay. These are the two. When there is a dual feeder, these are the arrangement to be made. Now how the generator is connected over here, that is we will show over here. Now in this 87G generator, there is another CT supply is coming, that is we will show over here. Now let us remove this part, then I will show how the generator is connected. Okay. Now we have seen that A bus and B bus, this feeder are connected, right? A bus and B bus is connected. So this is a bus and this is a B bus. A bus breaker and B bus both are connected. Now this is the terminal, suppose. Now from this terminal, what we will do now, we have to show how the generator, suppose this is A bus, this is connected, this is a B bus, this is connected, these are shorted. Now this is the terminal from where generator is connected. Now from here, it is going to where? It is going to the first. This is a 11 kV switchgear, but now our generator is a 6.6 kV. Okay, we have to keep in mind, switchgear is 11 kV, but the generator is a 6.6 kV generator. So to 6.6 kV to convert to 11 kV, we need a step-up transformer. So I have a transformer over here that is a 11 kV by 6.6 kV. Okay, so ultimately from these two panel, A bus panel or B bus panel, from the common point, the cable is not going to the generator, it is going to the transformer 11 kV side. This transformer is a delta star transformer. Okay, this is a delta star. This 6.6 kV is delta, and this side is a star. And then this delta side is connected to the where? It is connected to the generators, and generator neutral is grounded through a NER. Suppose there is a NER is connected over here, so we will show over here. This is NER, neutral earthing resistor, and then it is grounded. Okay. So now this generator is a 20 MVA generator at 6.6 kV. We have said this is the generator, and then this generator has a, you see here, this is the neutral point of the generator. So there will be a CT over here for the 87G. So this CT supply from here, where it will go? It will go to the 87G relay, generator differential relay, which is located in the bus B panel. So if this is the 87G relay, so this 87G relay, one supply coming from the generator, one supply coming from the A bus, and one CT supply coming from B bus. Okay. So this will be the arrangement for the 87G. So this CT, as it is 6.6 kV, we have seen this is a 1500 by 1 ratio for the feeder. So here the neutral side CT will be 3000 by 1, double, as the voltage is double, half, current rating will be double. So this the 87G CT, this CT, neutral side CT will be 87 by G. So this is from the field, it will come to the differential relay, generator differential relay, which is located in the switchgear B panel. Okay. So this is, and this transformer how much? This 20 MVA. So this will be 25 MVA, 5 MVA more, 25 MVA oblique maybe dual rating we can take 30 MVA. Because dual rating we can get by force cooling. If we put a fan, fan force, then I can get better higher MVA as per the MVA requirement. If the generator can give some 30 MVA, I can cater for this. That's why always transformer is taken slightly higher capacity than the generator rating. So this will be the single line of this generator feeder. So we have to show this A bus and B bus, that is inside switchgear, and this part, this is the boundary of the switchgear, and this part is in the field side. This will not come inside the switchgear area, it will come outside of the switchgear area, but this part also we need to show on the single line diagram. So if you see the generator single line diagram for the generator feeder, how overall it will be looking? It will be looking like this. I am drawing now. Suppose this is A bus and this is a B bus. Suppose this is a bus and this is a B bus. Okay. Now from here we have a isolator. Okay. This is a isolator. This is a breaker, and then all the CT over here. So this is coming over here. Similarly here also same arrangement. This is the isolator. Okay. This is a isolator. This isolator is coming over here. Then this is your breaker. So this is the second, and these 2 points are shorted. And then from the B bus, it is going to the generator. So from the B bus, it is going to the first generator transformer. From there, it is going to the generators. Then there is a neutral point. From the neutral point, there is a NGR and going to ground. This is a NER. Okay. And this is a CT, and there will be CT over here. That is a 87G CT for this. And there is a CT over here. Suppose this is a CT over here, and there is a CT over here. So it is connected to 87G generator differential. Okay. This CT supply also coming over here. So this will be the 87G connection. All other CT we have shown already. Okay. So these are the single line diagram for this, and here all the CTs are mounted over here. All the CT details we have already shown. How to write all the CT details, we have to write over here, and the B bus there is a PT over here, that also we have to show. So this is a single line diagram for the dual feeder, where a particular equipment is connected, whether it is a generator or it may be only the transformer. In case of compressor, suppose in case of compressor, this is a motor, it is not the generator, it is a motor, and then maybe the earthing is not there, this is a motor. In that case, the same way it will be connected, same arrangement. Okay. Now we will discuss about a single feeder, where the feeder is connected either A bus or B bus. Suppose there is a transformer of 5 MVA. This 5 MVA transformer is connected to the single bus. So what will happen in that case? In that case, same, this is isolator. In that case, suppose this transformer is connected to A bus. So on the A bus, how we will show this? This is our isolator. Okay. This is our isolator. This is our isolator. Okay. This is a motor driven isolator. And then this is our breaker. It is also motor driven breaker. Then there is one CT for the multifunction. This is a protection relay. This relay, suppose this is a protection relay. Protection relay. Then we have a multifunction meter. This is a multifunction meter. Then this CT is going to busbar differential. Busbar differential. At 87B I can write down simply. So not written 87B. So I need in that case only 3 CT. For this motor there is no differential protection. So I have a 3 CT. One is a protection relay CT. One is a multifunction meter CT. Multifunction meter. And one is a busbar differential CT. Suppose this motor is a 5 megawatt motor. This is a motor. This is the outside of the field. This is a switchgear boundary. This is the boundary of the switchgear, and this is a terminal over here. So from this terminal, this cable is going to this, and this is the busbar. Power is following this way, right? Now here all this CT in the same way, the ratio VA, protection class, all this thing will be written over here as the busbar differential same CT. So it is a 2000 by 500 by 1. Suppose VA 20 VA CT, PS class CT, all this thing will be there, and all this CT will be decided as per the rating of the respective equipment. So these will be coming over here. In addition to this, we have to mention the cable size also over here. Suppose this cable, this motor is a 185 square millimeter cable or 240 square millimeter. So suppose there is a 1 3-core cable, 1 3-core into 300 square millimeter cable for this motor, 300 square millimeter copper. So we will write over here that motor, that cable size. So from the single line also we will get the your cable size also. All the equipment details will be there. How many feeders are connected, that is also we can get. How the feeders are connected, what are the power connection, and what are the cable size here. Similarly, in the case of generator, we can get the same way. I have missed out the generator cable size. In the same way, if you see the generators, in the same way we can mention the cable size. In the case of generator, we have seen the same arrangement. So here is a breaker. Then all the CT, this is a terminal. These two terminals are shorted, and from here it is connected to the transformer. Then going to the generator, right? From this terminal cable is going to the transformer. So this cable will be 2 into 1 core into 400 square millimeter. 400 square millimeter per phase. This cable from the B bus, this terminal, the cable is going. This is the size of the cable. Okay, and this hookup cable, this is also hookup cable. That is also the same size. The hookup cable between A bus and B bus panel. From the A bus panel bottom or top, this cable will come out, going through the field, and it will enter to the B bus panel. That cable, it is outside of the field, because this size of cable you cannot take through the panel. So it is go outside of the panel, that cable, and from the B bus panel, the cable which is going to the transformer, both are the same size, 2 number 1 core, 400 square millimeter. That also we have to mention. In this way, cable size also we can mention in the switchgear drawing. So this is the overall single line diagram. How can now this is the two different type of feeder we have shown. In addition to this, in the switchgear drawing, this bus bar has the bus PT. That also we can show over here the bus PT. Then the bus bar, it is bus PT supply is going to the bus bar. So that bus bar is a continuously passing from one bus to other bus. So it is a continuous bus bar arrangement. So bus PT supply going to the bus. Similarly, bus B also there is a PT. That PT supply also going to B bus PT. So that bus bar, in addition to this bus PT supply, there is a control supply, 120 volt control, 48 volt control, 24 volt control, then your auxiliary supply. All this supply is going to the bus wiring. So that bus wiring we show on the inside the same drawing in this way. So this is a 120 volt bus bar which is running inside through one panel to other, one end to other end. From here we can tap up 120 volt supply to the respective panel. Similarly, 48 volt, 240 volt, bus VT, bus bar differential. The bus bar differential we have seen 2500 by 1 ampere CT. This CT supply is not going direct to the relay. It is going to the bus wire. From the bus wire, finally all this CT supply coming to the bus wire, to the bus bar, to the bus in the bus wiring. From the bus wiring, ultimately it is going to the relay, 87B relay. Okay. So in this way, this bus wiring also we can show. If there is a space, we can show also the various outside field interface also we can show. From here, suppose it is going to PMS, it is going to DCS, it is going to control panel, that also we can show on the single line diagram. These are the various way we can represent the overall single line diagram. But at the end of the day, when you complete the drawing will be showing all the feeders from the switchgear connected to the bus A and bus B, including their cable sizes. Okay, that is the way we make the single line diagram. At the end, when you complete the drawing, so drawing will be showing like, suppose this is a, I am drawing over here, my space is this here. So here all the feeder will be showing one by one. This way all the feeders, suppose this is going to generator 1. So this is A bus and this is a generator 1, this two going to generator A. Suppose this is going to transformer 1, transformer 2, this is going to transformer 3, this is going to transformer 4. So all this detail will be here, CTPT, everything will be there. Suppose this is going to motor 1, this is going to motor, suppose this is going to motor 2. So in this way all this feeder details, this means this entire CTPT, all the details are shown, I have shown in details, all will be showing over here. And then the generators will be, suppose this is going to generator, so in the same way you connected over here, this generator will be connected over here, this will be shorting, and it is going to generator, we show the generator over here. And this part will be inside the switchgear. This will be shown in this way. This is the switchgear part. Okay. And similar, here is a bus PT here, there is a bus PT, there is a bus PT, that also we can show over here. In this way we can develop the overall single line diagram. I am closing this video over here. Please go through. It is only the guideline how to develop the single line diagram. But in more detail, when you work on this, you will get the more details. And you can, depending on the situation, you can incorporate more and more information. So please go through this. If it helps you, that will be my pleasure. And I hope this will make a clear and real some tangible difference to all of you. If you go through minutely, please go through this and let me know if you have any comment. So I am closing this video with this. Thank you very much indeed. Thank you.